So hello guys, welcome again. This is a video for explaining the second problem statement, Hog-Rager. First, we are importing the importing JSON, and we were given corpus.json file. So we are loading that and extracting relevant metadata and article content and storing it in a list which we created with the name documents. So in each document, it has this things: title, author, sources, content, and we converted into a dictionary format, and then appended in the list. Here we are installing ChromaDB. This is very important step because basically ChromaDB is a database. We will be requiring database, so for that we are installing it. This step is very important as we are using BG large model. This is specifically model for converting the any content or whatever you say into embeddings. So by this we will convert it into embeddings. Here I would like to clear one thing, that here you can see we first converted all the content into the embeddings. Mainly we have to convert the content into the embeddings. We converted it, but this step takes a lot of time. So we, after converting into embedding, which we stored into a JSON file. So after next time when we will be running, we will not be taking so much of time again creating the embedding and doing the process. So we created a JSON file. Now we are opening that JSON file and we are updating the documents list which we made earlier with the embeddings. So first we are passing the embeddings into the document and that document into the documents list. Now we are creating this collection is basically a vector database. So now we are creating a vector database and passing this documents list, and here we are adding into collection vector database. And as you can see, collection.add, here basically main things to add were content and embedding. Generally we have to add all the things, so we added all the things, but title, URL, and that we combined it in one metadata and then added it. So here you can see 609 documents were added. Now this is for in this step we are creating a function to search documents by query. So what will be the query which we will be passing, or the user will be passing, on basis of that documents will be searched. And according to the problem statement, we want top 4 documents or top 4 relevant documents. So basically this step is for that. And after running this, you can see that we have been given distances, top 4 distances, and on the basis of that we are given metadatas, content, and all these things. Okay, in this step we are installing bits and bytes and transform accelerate. I explained it in the earlier problem statement. I am installing GPT for all. It is an open source model from which we will be extracting MetaLlama, or extracting not, but we will be using this model for summarizing the documents and creating the response. Basically we would be creating the answer in this tab. So our final answer according to the query would be generated, and final answer would be in either comparison. Basically query would be in 2 forms: comparison query or inference query. On the basis of that we are generating answer. So earlier the query which we passed was this. As you can see, has the advice provided by Sporting News. This was given in the problem statement document. So we passed this query and this was the comparison query, and so basically we got the answer according to that. The final answer is yes, and this is what we needed. And according to the final answer, we basically created the JSON, the final answer in the format which they asked. So this is all. Thank you.